Welcome to Project I2GROW. This is our system here at Virginia Tech. Let me walk you through it. The system is made up of a simple wooden frame, the FarmBot robot itself, water tanks for the hydroponic system, growth channels, a PC that runs our more advanced code, an environmental sensor in the back corner, and a small fan. Also, we have grow lights to help the plants grow better in an indoor environment. When you set up your FarmBot, you'll follow the instructions on the FarmBot website to connect all of the components to the brain of the system found right here on this PCB. You won't have to change anything on that once your FarmBot is set up. Then you'll create an online account with the FarmBot software and connect to your physical robot. Once everything is connected, you can program sequences or code that the robot can execute either directly from your computer, or you can connect it to these first three buttons directly on the FarmBot. Our first button is connected to a sequence that makes the robot go to the home position. When I click that button, the robot will move to the back corner, which we have defined as our home position. The last two buttons on the top of your FarmBot are the unlock or reset button and emergency stop. If I want my robot to stop executing a sequence, I can click the emergency stop button, followed by the reset button, so that it is ready to execute the next sequence that I send to it. After you've set up the PC, downloaded ROS2, and initialized your sensors, you can run the program like this. Log into your PC with your login credentials, and open a terminal by clicking Ctrl-Alt-T. A terminal will pop up where you can send code directly to your Linux PC. Now, from the GitHub, we're going to run the couple lines of code that start our system up. So, go into the ROS2 folder, make sure everything is initialized, and the last line of code will make the graphical user interface pop up on your screen, and the robot will begin executing the sequence that you set up for it. My sequence first goes home, and then goes to each plant location to take the images. So first, as you can see, the robot is going to its home position. As the robot moves to each plant and takes images, the images will begin to pop up on your graphical user interface. The robot will take measurements every hour. After the first few hours, weight estimates will start to show up as well. On the top left, you can see the estimated weight of the plant, and in the bottom right will be the prediction for what the plant weight should be. Since there are no plants in the system yet, it'll just say less than 1 gram and NA for the prediction. To end the program, reopen your terminal and just type Ctrl-C. This will close the graphical user interface. Your robot, however, will keep moving. To make the robot stop moving, as we have seen, you can click Emergency Stop, and then followed by Unlock, so that you can reset your robot. Now you can keep working on the robot or run the program again. All of the data collected will be saved directly on your PC. Go to Files and find ROS FarmBot data. In this folder, you'll find another folder with all of your images, which are currently binary files but can be converted into JPEG images, for example, and will look like this. Also in the ROS FarmBot data folder is your light intensity data, which you may have inputted manually, your environmental sensor readings, and weight estimates. All of this data is automatically saved and can be accessed at any time. We hope you enjoyed this tutorial for our I2GROW robotic system. Good luck!